bent molecule because the lone pair will suppress these bonds. So it's bent or angular or V-shaped. You can say this bonding angle is not 180. One important is that SO2 is a toxic gas. It is a toxic gas having irritating smell, and it is released naturally during volcanic eruptions, and is a good reducing agent. It is a good reducing agent also. It is also a bleaching agent. It is also a bleaching agent, and its bleaching is temporary, and bleaching is temporary. Because its bleaching action is temporary. Why? Because it bleaches by reduction. Okay, so when the bleached paper, pulp or cloths, when gets exposed to air or atmospheric air or atmospheric gases or O2, then O2 reoxidize the reduced dyes and the color reappears. So you can say that the bleaching action of SO2 is temporary, but the bleaching action of Cl2, that is chlorine, also acts as a bleaching agent. H2O2 also acts as a bleaching agent, and their bleaching action is oxidative bleaching. So their bleaching action are not temporary, they are permanent. So what we have learned that the bleaching action of SO2 is temporary, whereas bleaching action of chlorine or H2O2 is permanent. Okay, so let's find out the number of p pi or p pi d pi bond in SO2. So first of all, we have to find out the hybridization. There is one sigma bond and one sigma bond and one lone pair. So 2 plus 1, that is 3. This is the steric number, and it will give you sp2 hybridized. So this sulfur is sp2 hybridization is sp2. So what we can say that this sulfur uses 2 of its p orbital in hybridization, but 1 p orbital is left with it. So 1 pi bond, say this one 1 pi bond will be of p pi nature, because 1 p orbital is left, and 1 pi bond will be d pi p pi nature. So in SO2 molecule, one bond is p pi and one is p pi d pi. Okay. Anion. This is the peroxy disulfide anion. Let's draw the structure of it. This is the structure of peroxy disulfide anion. There is a peroxy linkage in it, and it is the anion of Marshall acid. That is a popular peroxy acid in which peroxy bond is present, peroxy linkage is present. So first of all, we have to find out the hybridization. This sulfur has 1 sigma bond, 1 sigma bond, 1 sigma bond, and 1 sigma, 4 sigma bond, and 0 lone pair. So steric number is 4. So this is sp3 hybridized. So this sulfur is sp3 hybridized. Similarly, this sulfur is also sp3 hybridized. Okay. Next, we see that all the p orbitals of sulfur has been used up in the hybridization. So for this formation of 2 pi bonds, sulfur will use its d orbital. So bond will be p pi d pi. This will be also p pi d pi. Similarly, this bond also will be p pi d pi, and this will also be p pi d pi. Perchlorate anion, that is the ClO4 minus. This is the perchlorate anion, and the structure is this one. One oxygen is singly bonded, so there are 3 lone pair and negative charge. There is 1 sigma bond, 1 sigma bond, 1 sigma bond, and 1 sigma bond. There are 7. This is the chlorine. There are 7 valence electron of chlorine, and all the electrons have been used up in the hybridization. So there is no lone pair left. There is 4 sigma bond plus 0 lone pair. So there is 4 steric number, that is sp3. So all the p orbital of this chlorine has been used up in hybridization. So chlorine will use its d orbital for the pi bond formation. So this will be p pi d pi. Again, this will be p pi d pi, and this will also be p pi d pi. Our next question. Molecule, it's a very popular molecule. It is prepared by reaction with white phosphorus with excess of oxygen. It is 5O2 and P4. We give you P4O10. So in plenty of oxygen you will got P4O10. It is a powerful dehydrating agent. It is a powerful dehydrating agent. Dehydrating agent. Other dehydrating agent may be. Apart from this, other dehydrating agents PPF4 also and lime also. H2SO4 is also a good dehydrating agent. So let's draw the structure of P4O10 or P4O10. This is the structure of P4O10 molecule. So here we can see that this phosphorus is forming 4 sigma bond and there is no lone pair, so the hybridization is sp3. So all the p orbitals of this phosphorus has been used up in hybridization. So this bond will be of d pi nature. Similarly, this will also be p pi d pi. This will also be p pi d pi, and this bond will be also p pi d pi. So we can say that all 4 PO bonds are of p pi d pi nature in P4O10 molecule. This is the trimer of SO3. Trimer of SO3 is this one. Here structure is SO, S, O, S, O, S, and there are 2 oxygen bond, oxygen atom bonded to H sulfur. So first of all, let's find out the hybridization of the sulfur atom. Here we can say sulfur is forming 6 bonds. There is sigma, sigma, sigma and sigma. There are 4 sigma bond and 2 pi bond. Each sulfur is forming 4 sigma bond and 2 pi bond. So what is the steric number? So steric number is number of sigma bond 4 plus lone pair is 0, because there are 6 bond, 1 bond, 2, 3, 4, 5, 6. 6 electron has been used up in the bonding, so there is no lone pair left. So 4 and the hybridization is sp3. So again we can say that all the p orbital of the sulfur has been used up in the hybridization. So all the pi bonds, for example this one, this one, this one, this one, this one and this one, all will be of p pi d pi nature. So in SO3 molecule all 6 pi bonds are of p pi d pi bond. So that's the end of my lecture.